Section 8.3, graphing f of x equals ax squared plus bx plus c. We're first going to talk about maximum values and minimum values. The maximum value is the y-coordinate of the vertex of a function in the form f of x equals ax squared plus bx plus c when a is less than 0. So the reason why it's the maximum value, let's put some numbers in here. Let's say that f of x equals, a's got to be less than 0, so let's make it negative 3x squared plus 2x plus 4. Because of the a value being negative, less than 0, we know that we're going to have a parabola that opens down. So therefore, the vertex will be on top. So it will have a maximum value. So you know it's a maximum value when you have a negative a. And the maximum value would be the y-coordinate of the vertex, which we will talk about in a little bit. The minimum value is the y-coordinate of the vertex of a function in the form f of x equals ax squared plus bx plus c when a is greater than 0. So let's give an example here. If f of x equals, we need to be greater than 0, so let's say 1/2 x squared plus 3x minus 10. All we care about is this being positive. Therefore, the parabola would open up. And your vertex would be on the very bottom, so there would be a minimum value, and the minimum value would be the y-coordinate of that vertex. So far, every graph that we've done in section 8.1 and 8.2 has had a vertex located along the y-axis. So we had the vertex here, and then it would go down, open down, or we would have the vertex here on the y-axis, and it would open up. But if you realize, most graphs, or many of them, do not have the vertex on the y-axis. Here, in this example, the vertex is not located along the y-axis, which is right here. It's to the side of it. So the main difference between sections 8.1 and 8.2 and now into 8.3 is we now have the middle term. So if you remember, 8.1, we just had y equals ax squared. That was section 8.1. 8.2, we had y equals ax squared plus c. And now we have the whole entire equation of y equals ax squared plus bx plus c. And so when we get to this, our vertex is not necessarily going to be on the y-axis, where these two equations, your vertex will be on the y-axis. All right, so let's fill in some of this information. So the graph opens where? Up or down when a is greater than 0? And the answer is it opens up when a is greater than 0. The graph opens down when a is less than 0, and we talked about this at the beginning of these notes. The blank is the c. So when we look at these formulas, and we've talked about this already, c is going to tell us what about the graph? And c is going to tell us the y-intercept. It's where it crosses the y-axis. So let's write that in. Y-intercept. The blank of the vertex is negative b over 2a. So the x-coordinate, and I'll talk more about this in a second, but the x-coordinate of the vertex is negative b over 2a. And finally, the axis of symmetry. So that's where if you fold it, the graph ends up on itself. The axis of symmetry is x equals negative b over 2a. So the x-coordinate, negative b over 2a, when you put x equals negative b over 2a, that is your axis of symmetry. So let's talk about this. A vertex. When you look at a vertex, it's going to have two coordinates. You have your x-coordinate and you have your y-coordinate for that point. So when you're given an equation, f of x equals 2x squared plus 8x minus 1, since the middle term is here, the vertex isn't going to be on the y-axis anymore. We need to find the vertex, and by doing that, we use this nice new formula that we're given, negative b over 2a. So we need to find, let's write right here, vertex. And your vertex has two parts. It has the x-coordinate and the y-coordinate. So for the x-coordinate, we're going to use negative b over 2a. Well, if you don't know what b and a are, let's verify what they are. This formula is ax squared plus plus bx plus c. So, and y equals, or your function f of x equals. So a would equal 2. It's the one being multiplied to x squared. B is being multiplied to x, which is 8, and c is your constant term, which in this case is negative 1. So now let's plug that information into the formula. Negative b would be negative 8 over 2 times a, which is 2 times 2. So we have negative 8 over 4, that's negative 2. All right, that is your x-coordinate of your vertex. So your vertex will be negative 2, comma, we need to figure out what the y-coordinate is. So the y-coordinate, in order to discover that, you literally take your equation, f of x equals 2x squared plus 8x plus 1, and you plug the x of negative 2 into the x spots and solve for y. So here we go. Y equals, or the y-coordinate, we're going to do y equals 2x squared plus 8x minus 1, and we're going to plug in negative 2 into the x's. So we get 2 times negative 2, square that, plus 8 times negative 2 minus 1. So negative 2 squared is 4 times 2 is 8. And then 8 times negative 2 is negative 16 minus 1. So when we add these or subtract them, 8 minus 16 is negative 8 minus 1, negative 9. So that is your y-coordinate of your vertex. So the vertex of this graph, this function, would be at negative 2, negative 9. Now the axis of symmetry, it says find the axis of symmetry and the vertex of this function for this graph. The axis of symmetry is just whatever your x-coordinate is, you make it x equals negative 2. And that is your axis of symmetry. So just to bring this all together, over to the left, there might be a little space. I'm just going to draw this. So I'm not going to make it perfect, the graph. But what we've discovered is that the vertex is at negative 2, negative 9. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9. So your vertex would be here. And I don't have the other, well, we know that it's going to cross the y-axis at negative 1. And we know that because our c value is negative 1. So let's put a point at negative 1 on the y-axis. And then we'll try to connect those and draw a parabola curve. So that's the vertex going, and that is not the prettiest graph, but you get the point. And the axis of symmetry is where it would fold in the middle, and that we said was x equals negative 2. So that would be this line right here. And that is your axis of symmetry. All right, so I want you to pause it and do part B on your own. Take a couple minutes, find out the axis of symmetry and the vertex. Unpause it and check your answer. So for part B, your vertex would be at 7, 20 and a half, or you could have said 7 and 41 over 2. And then your axis of symmetry is x equals 7. Okay, for example 2, we're going to graph now the function 3x squared minus 6x plus 5. So we know that it will cross the y-axis at positive 5, but we don't know the vertex. So let's find the vertex using the formula we just used. So we have vertex, our x value would be negative b over 2a. So b is negative 6. So the opposite of negative 6 would be positive 6 over 2 times a. Our a value is 3. So it would be 6 over 6. So we get 1 for the x value of the vertex. So 1, comma, we don't know what the y is. But let's figure out the y right now. We have the y value is equal to 3, and instead of writing x, we're going to plug 1 into x's spot. So 1 squared minus 6 times 1 plus 5. So 1 squared times 3 is 3. So y equals 3, and then 6 times 1 is 6, so minus 6 plus 5. So your y value would be 3 minus 6 is negative 3, plus 5 would give you 2. So that's the y-coordinate of your vertex. So when we graph it, the vertex would be at 1, 2. So let's just put that on the graph. So we go over 1, up 2. So when we figure out how to graph this, since 3 is greater than 1, we know that this is going to open up and this is going to be the minimum value. So we can't solve for the x intercept because it's never going to cross the x-axis. It's going to go up. So what I would suggest you doing is make a table, x values, and what is the f of x value when you have your specific x values. Now, the middle, I usually grab about 5 points on a graph. The middle value is the vertex. Now, we've always done 0, 1, 2, -1, and -2, but our vertex is no longer along the y-axis. So I'm going to plug in our vertex here. When x is 1, f of x is 2. So let's plug that in. When x is 1, f of x is 2. That's our vertex. Now to find the other x values, I would just go out from 1. So we go 2, 3, and then here 0 and -1. So let's plug in 2. Let's go 2 and 3 first. So when we have the function f of x equals 3x squared minus 6x plus 5, let's do f of 2, which equals 3 times 2 squared minus 6 times 2 plus 5. Okay, 2 squared is 4, times 3 is 12, minus 6 times 2, which is 12, plus 5. 12 minus 12 is 0, plus 5 is 5. So when x is 2, y, or f of x, is 5. So since this 1, 2 is the vertex, if I go on either side equally, so jumps 1 up, 1 down, if this is 5, this should be 5 as well. So let's plug it in just to make sure. So we have f of 0 is equal to 3 times 0 squared minus 6 times 0 plus 5. Well, 0 squared is 0 times 3, 0, minus 6 times 0, which is 0, plus 5. And sure enough, that would be 5 as well. Let's find out what f of 3 would be. So we would have 3 times 3 squared minus 6 times 3 plus 5. 3 squared is 9, times 3 is 27, minus 6 times 3, which is 18, plus 5. 27 minus 18 is 9, plus 5, and we get 14. And if we plug in -1, we would end up getting 14 as well, because if I just plug it in verbally, we have -1 here. So -1 squared is 1, times 3 is 3. Negative 6 times negative 1 would be positive 6. So 3 plus 6 is 9, plus 5, we get 14. So let's graph these points. We have 2 over 2 up 5. So over 2, 1, 2, up 1, 2, 3, 4, 5. We're about right there, and it's sometimes hard to get on the graph. 0, x is 0, up 5. And then for the 3 and 14, we're off the graph, but that's okay. So we go to the right 3. If this is 10, we'll go 11, 12, 13, 14. So we'll go right here. And then negative 1, 14 would be there. So there is your parabola for that function. Please pause the video and do B on your own. So here's your answer for part D. All right, example 3, finding the maximum and minimum values. So tell whether the function f of x equals negative 4x squared minus 24x minus 19 has a maximum or a minimum value. Then find that value. So when we look at this function formula, we see that a is negative 4. So if this is less than 0, we know that the parabola is going to open down. Therefore, the vertex is going to be on top, which means that we would have a maximum value because that would be at the top of the graph. So the maximum amount. And the maximum value would be the y-coordinate of the vertex. So now we have to find the vertex. Vertex x would be negative b over 2a, which is 24, because it's negative 24 in the function, so the opposite of that is positive 24 times 2 times negative 4, or over 2 times negative 4, which equals 24 over negative 8, which is negative 3. So the x-coordinate of your vertex is negative 3, but we need to find the y-coordinate to find the maximum value. So y equals negative 4 times negative 3 squared minus 24 times negative 3 minus 19. So negative 3 squared is 9 times negative 4, we get negative 36. And then negative 24 times negative 3 would be a plus 72 minus 19. So then we're going to do negative 36 plus 72. That's 36. We still have to subtract the 19. So your final answer would be 17 for the y-coordinate of your vertex. So this maximum value, if this was on the graph, it would be, you would graph it to the left 3, negative 3, up 17. So the top value is 17. One thing I forgot to do, and you may have caught it already, we're going to go back to example 2. And it says describe the domain and range. So I graphed the function, but I didn't complete this. So if you've already done it, great. You guys know the answers to these. So the domain, I'll write it up here. The domain for f of x equals 3x squared minus 6x plus 5 would be all real numbers. Okay. And the reason being is if you look at all your x values, this graph will continue to go out to the right and to the left forever and ever and ever. So any x value will have a place on this graph. For the y values, the range, they would be any value starting at 2 and then going up. So we would write y is greater than or equal to 2 because it does include the value of 2. So that's your domain and range for example 2, part C. And for part D, hopefully you said domain is all real numbers and the range is y is greater than or equal to negative 1. This concludes your notes. We will continue with example 4 tomorrow in class. You may now work on your journal page.